We are going to start now the second lecture of our chapter 7 of class 9 mathematics, triangles. So in this lecture we will talk about the congruence of triangles. So the first thing is the definition of the congruent figures. So congruent figure means exactly same figures we are talking about. They are called the congruent figures. So if suppose I am talking about a straight line, this is AB, and I am talking about another straight line, say CD. So we are saying if length of AB is equal to length of CD, it means these two lines we are talking about, then these are exactly same shape. So these two lines, these are called the congruent lines. If suppose I am talking about two angles, this is one angle and say this is another angle, the value of this angle is x, this angle is also x. It means the measure of both these angles, it is same. This is measure of this angle is, we are saying it is x, and measure of this angle, say I am saying this is A O B and this is A dash O dash B, and measure of A dash O dash B angle, this is also equal to x. So both the measure of both these angles, they are equal. So both these angles, these are congruent. Over here both these lines, these are congruent. So congruent is that if we superimpose the things on each other, they cover each other exactly. Similarly, we have the definition of congruent triangles. So two triangles are congruent if and only if one of them can be made to superimpose on the other so as to cover it exactly. So basic definition of congruent, when we are term congruent we are using, it means we are saying they are exactly identical as shapes. Suppose we are talking about two triangles ABC and DEF. So we are saying that if angle A is equal to angle D, then angle B is equal to angle, this is E, this is E over here, we are saying angle B is equal to angle E, and angle C, that is equal to angle F. Then next we are talking about, these are the angles, then we are talking about the sides. We are saying the side AB, that is equal to the side DE. Then we have side AC, that is equal to the side DE, and last the side BC, that is equal to the side EF. We are given two triangles ABC and DEF. If all of its angles are equal and all of its sides are equal, then we say that the two triangles, they are congruent. Now next we have some results over here. We are saying every triangle is congruent to itself. It is clear to you that if we are saying ABC is for congruent, we are using the symbol like this. This is the symbol for congruent we are using. So we are saying ABC, triangle ABC is congruent to itself. Second, we are talking about if triangle ABC is congruent to triangle DEF, then it means DEF is congruent to ABC. Third is if three triangles are given to us and first is congruent to the second and second is congruent to the third, then we have first is congruent to the third. We are saying first and third, they are also congruent. First and third, they are also congruent, and we use the abbreviation, it is CPCT. Whenever we are writing it like this, it means it is corresponding parts of congruent triangle. So corresponding part of congruent triangle means if I am talking about that triangle ABC is congruent to triangle DEF, I'm talking about these two, then what this thing mean is, we are saying angle A is equal to angle D. We are saying angle C is equal to angle F. Similarly, the third angle. If I am talking about side BC, that is equal to EF. So this thing, it is corresponding parts of so these are corresponding parts, A and D, C and F, BC and EF. Now, if suppose in place of this, I am saying that triangle ABC is congruent to triangle, say, EDF. So in this particular, say, I am saying AB is congruent to DEF. So what is the correspondence over here? That A and D, B and E, and C and F, and these angles, they are equal. Then we are saying, if we consider the side AB, that will be equal to DE. Now if in place of this, I am talking about this condition over here, if I have written triangle ABC is congruent to triangle EDF, now the correspondence over here is A and E, B and D, C and F. This is the correspondence over here. So if I have to give the example, in this case I am talking about this triangle. Suppose this is the triangle, this is A, B, C. Now I am talking about another triangle over here. Now what we have is the correspondence of A is with E. So we are saying it is E over here. Corresponding to A, this point, this vertex is E. Corresponding to B, the vertex we have, it is D. And corresponding to C, the vertex we have, it is F. So for A we have E, for B we have D, and for C we are saying it is F. So these two triangles, they are congruent. We are saying these two triangles, they are congruent, and their corresponding parts will be like AC is equal to EF. So we have to look at the figures, and accordingly we will decide that what are the corresponding parts and how those two triangles, they are congruent. Now in the previous slide, we have seen that if two triangles are given to us, then all three angles and all three sides, all three angles are equal and all three sides are equal. But suppose we are given two triangles and we do not know whether they are congruent or not. So is that necessary that we have to check all the sides and all the angles? We are talking about that two triangles ABC, a triangle ABC is given to us, and another triangle, say DEF, is given to us. Now if it is given that angle A is equal to 60 degree, we are saying over here angle D is equal to 60 degree. Second thing that we know about these triangles is that in this triangle, the side AB is equal to 3 centimeter and side AC is equal to 4 centimeter. In this triangle, we are saying DE is equal to 3 centimeter and DF is equal to 4 centimeter. We only know this much about these two triangles. We do not know the other angles, we do not know the other sides. So can we tell whether these two triangles, these are congruent or not? So now our next few results, they are concerning to this problem. So we are saying the first result we have is SAS criteria. So this is first criteria. What it says is, if two triangles have two sides and the angle included between them, the corresponding sides, they are equal. But we are saying that we are given two triangles now. We are saying this is triangle ABC and there is another triangle given to us, that is DEF. F. For these two triangles, what is given to us is that the angle over here it is 60 degree and the length of the sides is given, that is this side is 3 centimeter, 4 centimeter, 3 centimeter and 4 centimeter. Now what our criteria says is that if we are given two triangles, there two sides we are talking about, this is 3, this is 3, this is 4, this is 4, two sides are equal and the angle in between these sides, they are equal. If these three conditions are satisfied, then we will say that these two triangles, these are congruent. We need not to check whether all the sides and all the angles are equal. This much condition is sufficient that two sides and the angle between them, they are same, then the triangles, they are congruent. Now first we prove this result that this much is sufficient for us. To prove this, what we are saying is, we are given two triangles, it is shown in this figure, ABC and DEF. Further it is given that this AB is equal to DE, AC is equal to DF and this angle is equal to angle D. Now what we have to prove is, we are saying that if these three conditions are given, then rest all the conditions, they are automatically satisfied. All other condition means we have to prove that angle B and angle E are equal, we have to prove that angle C and angle F are equal, and we have to prove that these two sides, these are equal. So to prove this, what we are going to do is, we place triangle ABC over the triangle DEF such that A falls on D and AB falls on DE. Now what we are saying is that these are the two triangles given to us. One is this triangle, it is A, B and C. We are talking about this first triangle. And second is this triangle DEF. What we are going to do, we are going to place this first triangle ABC on DEF, and suppose we are getting the figure like this. This figure I am talking about, we have placed this triangle on this. So this is the point A and D, this is B and E. Why it is like this? Because this angle is same in both these cases, this angle is same, it is given. The length of these sides, these are equal, the length of these sides, these are also equal. Now what we have is, I am coming to the proof part. We are saying since AB is equal to DE, so B falls on E, and since AD is angle A and angle D, they are equal, so AC will fall on DF. And further it is, what we have is that AC is equal to DF. It is also given to us. So C will fall on F. What we are saying is that our C and F, they will also coincide. We are saying they will also coincide. So AC and DF, we are saying they will coincide, and because these sides they are coinciding, these points they are coinciding, so it means these two lines we have, that is BC and EF, will also coincide. So we are saying that triangle ABC coincides with triangle DEF. So triangle ABC is congruent to triangle DEF. So basically what we are saying is that this side is equal to this and this angle is equal to this angle. We are saying these two angles will be equal and this side will be equivalent to this third side over here. So what we get from this is that if we have to prove that two triangles are congruent, then it is sufficient to prove that there are two sides, this S and this S, this represents two sides And why A is in between these two? Because it is angle between these two sides. This is very important over here, that it is angle between these two sides. It is not any angle we are talking about. Now next theorem we have to prove is the angle opposite to two equal sides of a triangle are equal. So we are talking about this thing, that a triangle is given to us and these two sides, these are equal. We have to prove that the angle, this angle will be equal to this angle. This thing we have to prove, that these two angles, these are equal. So to prove this, we are making a construction. So that is, we have drawn AD, where this AD is the angle bisector of angle A and it meets the line BC at D. We are talking about this AD. So what we have is, if the value of this angle is X, then the value of this angle is also X. This is the angle bisector we have drawn. We have drawn the angle bisector. Now we are talking about two triangles. The first triangle is ABD and second triangle we are talking about is ADC. These are the two triangles we are talking about. So if I draw these two triangles separately, I have one triangle is ADB and second triangle I am drawing over here, it is ADC. Now in these two triangles, what we have is the length of this side. This is same. Why? This is common side. We will write it is common. This side we are talking about, this is common. Now second thing we are talking about is that this AB is equal to AC. Why? These two, these are equal because it is given. Now the third thing we have is that this angle over here at A and this angle over here at B, both these angle they are equal. Why? Because AD is angle bisector. Both these angle, these are X. We have already written both these angle, these are X. So what we see is that both these triangles, they are congruent. Their congruent parts are A and D and D, B and C. So if I am writing the triangle ABD, I am writing it is congruent to triangle corresponding to A, it is A, corresponding to B it is C, and corresponding to D it is D. So triangle ABD is congruent to triangle ACD. So what we get is that angle B will be equal to angle C. These two triangles, these are congruent. So what we get is angle B is equal to angle C. Why? CPCT, congruent part of it is corresponding part of congruent triangles. Now the next criteria we have, it is ASA criteria. So from the name it is clear that we are talking about this is angle, side and angle. So we are saying, suppose we are given two triangles ABC and DEF. If angle B is equal to angle E, angle C is equal to angle F, and the side we are talking about, say it is BC is equal to EF, that is the side between these two angles. If these three things they are equal, then we are saying that the triangles will be congruent. We have to prove this thing. So to prove this, the first condition we are considering over here, we are considering two cases. The first case we are considering over here, that AC is equal to DF. We are saying suppose AC that is equal to DF. When AC is equal to DF, what we have is this AC is equal to DF, BC is equal to these two are equal, and the third thing we have it is that these two angles are equal. So what condition we have? This is side, angle and side are equal. So by SAS criteria we have these two triangles, they are congruent. So if this is for the case when AC is equal to DF, then by SAS criteria these two triangles, they are congruent. Now in the second case we are saying, suppose AC is not equal to DF. So what we are doing is we are constructing some point D such that D dash F is equal to AC and join D dash and E. So what we are saying, if suppose these values, these are not equal, then on this line I am talking about FD, this is the line FD I am talking about. On this line I can find another point. Suppose say I am saying this point D dash is there, so that the length of this D dash F is equal to AC, or D dash may be outside this FD, and this is mentioned in this diagram. We are saying we are trying to find a point D dash, it may be over here, it may be over here, such that the length, if suppose the length of AC is X, we are saying we are trying to find some point D dash such that the length of this is also X. Why? Because in this case we are considering that AC is not equal to DF. Now if these two lengths, suppose I am saying this is the point D dash, so what we have two triangles now. One is the triangle ABC, and second triangle we have it is D dash E and F. In these two triangles we are saying that this angle at C and this angle at F, they are equal, they are the common angles. We are saying the length of AC is X and the length of D dash F is X. Further we are saying that the length of BC we are talking about, suppose it is Y, this length is Y, and it is given that this length is equal to the length of EF, this length is also Y. So again by SAS criteria these two triangles, these are congruent triangles. So we are saying that the triangle ABC is congruent to triangle D dash EF. Now if these two triangles, they are congruent, it means that the angle at B and angle at E, both these angles will be equal. The angle we are talking about, the angle at B and angle at E, they will be equal. Now from the given question, what we have is, in this figure we are saying that angle ABC, that is equal to angle DEF. We are talking about that angle ABC is equal to angle DEF. Now from the second figure we are saying the angle ABC over here, that is equal to angle D dash EF. We are talking about two results. From these two we are saying angle ABC, that is equal to angle DEF. From this figure, from this condition, we are having angle ABC, that is equal to angle D dash EF. So if we look at these two conditions over here, what we get is that angle DEF and D dash EF, they are equal. So what we are saying is that we want to find some point D dash. We are saying both these angles, this angle we are talking about D dash, and this larger angle we are saying this is D, and these two angles should be, these two angles should be equal. If these two angles are equal, it means that both these points, they should coincide. Coincide means they are the same points. So what we get is that the triangle ABC and DEF, they are congruent. Now the next criteria we have, it is A and S criteria. A and S means we are talking about the two angles and a side. In the previous one it was ASA. We are saying two angles and side in between those angles. Now we are saying that two angles and any one of the sides, they are equal, then the two triangles, they are congruent. So its proof is quite simple. We are saying, suppose angle A is equal to angle D, angle B is equal to angle E. So the value over here it is Y and the value over here it is X. Now if we have to find the third angle in both the cases, in this case the third angle will be 180 minus X minus Y, because sum of angles of a triangle is 180 degree. Over here this angle will be 180 minus X minus Y. So what we get is that both these values, these are also same. So if two angles of two triangle, they are same, then the third will be automatically same. Now what we have is angle B is equal to angle E, BC is equal to EF, and angle C is equal to angle F. And what this is angle side angle criteria. What we have started with is, we are saying we are given two angles and one side, they are equal. From this we are talking about, if two angles are equal, then third is automatically equal. If two angles are equal, then third angle is automatically equal. So we get angle B is equal to E, BC is equal to EF, angle C is equal to angle F. This is the criteria ASA, and by the criteria ASA we get that ABC triangle, that is congruent to triangle DEF. Now next thing we have to prove is that if two angles of a triangle are equal, we are saying a triangle ABC is given to us, and in this triangle angle B is equal to angle C. We have to prove that the side opposite to them are also equal. So side opposite to C is AB and side opposite to B is AC. We have to prove that AB is equal to AC. So first thing we are going to do is, we are going to draw the bisector of angle A. If this is bisector of angle A, then both these angles, these are equal. The value of both these angles, this angle is X and this angle is also X. Now consider two triangles, one is ABD and second is ADC. I'm talking about the two triangles, one is ABD and second we are talking about is ADC. In these two triangles we are saying both these angles, these are X. This side is common, so these two sides will be equal, and what is given to us is that this angle B and this angle C, these are equal. This is already given to us, that if its value is Y, this value is also Y. So what we get is that triangle ABD is congruent to triangle corresponding to A, it is A, corresponding to B it is C, and corresponding to D it is D. We are saying both these triangles, they are congruent. So from this result what we get is that AB is equal to AC. The reason being, these are the corresponding parts of congruent triangle. Now the next criteria we have, it is SSS. It is clear. SSS means we are talking about three sides are equal. We are saying if all the three sides of the two triangles they are equal, then the two triangles they are congruent. So we are considering two triangles over here. One is the triangle ABC. So this is the triangle we are talking about. This is ABC, and the second triangle we are talking over here, it is triangle, say it is B, so it is D, E and F. This is the second triangle we are talking about, and we are saying that the corresponding sides are equal. Corresponding sides are equal means we are saying AB is equal to DE, AC is equal to DF, and BC is equal to EF. Corresponding sides are equal. We have to prove that these two triangles they are congruent. Now we are going to make a construction, and how we are going to do it is, suppose we are saying that the angle at B, this is X, the angle at C, it is Y. Now at this point E, we are going to draw a line at an angle X. This angle we are saying over here, we are saying suppose BC is the longer side, these two angles, this is X and this is Y. Now at the point E, we are going to draw a line at an angle X. At the point C, we are going to draw a line at an angle Y. This line is there, this is at an angle of Y degree. The point where they meet, we are saying that point is G, and we are connecting the point D and G. Now in the triangles ABC and GEF, we have that both these angles, these are X and Y, and the side we are talking about EF, we are saying that is equal to BC. It is given to us that side EF, that is equal to the side BC. So what we are saying is that the triangle ABC is congruent to the triangle. Now corresponding to A, it is G, corresponding to B, it is E, and corresponding to C, it is F. Corresponding to C, it is F, this, and corresponding to A at this point is G. And what criteria we are using? It is ASA criteria. These two triangles, these are the congruent triangle. Now what we have is, by the CPCT, that angle A, that is equal to this angle EGF. This is by CPCT. We are saying these two triangles, these are congruent. So we have is angle A is equal to angle EGF. Now side AB, that is equal to the side EG, and side AC, that is equal to the side GF. Further, these sides are already given to be equal. Now if we consider this triangle EDG, we see that the side, this ED and EG, they are equal, and from the previous result we know that if these two sides are equal, then these two angles, these are also equal. Suppose we are saying the value of this angle is X, XY we have already used, so in place of X we write, suppose the value of this angle is Z. Similarly, if we consider the triangle DGF, what we get is, if we consider this triangle, we are saying that these two sides, these are equal, that is DF and FG, they are equal. It means the angle opposite to them, these two angles will be equal. Suppose the value of this angle, we are saying it is T, or say it is W, and the value of this angle, it is W. So what we get is that this total angle over here at D, it is Z plus W, and this total angle over here, it is Z plus W, and we have already proved that these two angles, these are equal. So what we get is that the value of this angle at A, it is Z plus W. So finally what we have is, if we look at the triangles, I'm talking about A, B, C and the triangle D, E, F. We have the side AB that is equal to the side DE. Next, angle at A, we have proved it is equal to angle at D, and AC side that is equal to DF. Now what this thing correspond to? Is correspond to SAS criteria we have, and by SAS criteria we are saying both these triangles, these are congruent. So we have proved that if three sides of a triangle are equal, then the triangles will be congruent. It is important to note over here that we have not proved any criteria like A. This is not any criteria. The first one we have, it is SAS. Next we have it is ASA. Then we have AAS, and last we have it is SS and S. These we have studied. There is no criteria like AAA, that is if two triangles are given with all three angles equal, then they need not be congruent. This thing we will see further, but it is very important to note over here that if two sides and angle between them, these are equal. We are saying if two triangles are given, if this side is equal to this side is equal to this, and the angle between them, these are equal, then by SAS criteria the two triangles, they are congruent. If two angles and a side are equal, then they are congruent. If all three sides are equal, then they are congruent. There is no criteria we have studied A and